Okay, we're going to start off with an exponential graph. And the question says on the PowerPoint, the graph of f of x is equal to 3x. And the first question is to find f of minus 1. So we basically want to find the inverse of the exponential function called y equal to 3x. And we know that the inverse of an exponential will give us a log graph. So quickly, we're going to do that. And f of minus 1 of x is equal to log x base 3. So if you want to know how I got that, we're very quickly going to go through that. So the rules to find an inverse is, firstly, you swap x and y. So that equation would become x is equal to 3 to the power y. And then we're going to solve for y, and y is equal to, whenever you're solving for an exponent, you will bring in a log. So y is equal to log x, and your base is 3. And then we write that in inverse notation, which gives us f minus 1 of x is equal to log x base 3. So there we have our first one. We're finding the inverse. The second question here wants to know to sketch the graphs of y equal to f minus 1 of x. So we're going to go to the second question, and I'm going to delete that from the screen. So if we look at the second question, we want to draw the inverse. And if you remember in class, an inverse simply means swap x and y. So if we look at the graph, on the x-axis, actually on the y-axis, it's cutting the graph at 1. So that 1 needs to move to 1 on the x-axis. You'll also notice that the x-axis is your asymptote. So the inverse graph, the y-axis will become the asymptote. And if you want, we want a strategic point. So if we look at this point I have highlighted, this point is in terms of coordinate 1, 3. So the inverse of 1, 3 would become 3, 1. So let's quickly go and draw this graph. And as you can see, we just need 2 critical points. And the point 1 on the y-axis moved to 1 on the x-axis. And there's our point 1, 3. It moved to 3, 1. 1, 2, 3, 3, 1. So if we move those 2 points, and remember that your x-axis was your asymptote, so now your y-axis becomes your asymptote. And there we have the first part. That is the inverse of the original graph. The next part of the question says, go and draw, sketch y equal to, now we're looking at the inverse graph, and we notice that there is a translation. The graph has moved 2 units to the left. So f of minus 1 of x minus 2, we want to move this graph 2 units to the, sorry, I said left, actually 2 units to the right. It's x minus 2. And if we solve for x, we'll get plus 2. So this blue graph needs to move 2 units to the right. And that's very simple to do. The asymptote will have to move 2 units, 1, 2. So there's our asymptote is going to go there, where x will be equal to 2. This point 1 that we see now needs to move 2 units to the right. 1, 2, it'll move to the point called 3. And then we can take this point here that we said was 3, 1. And we can move that point 2 units, 1, 2. So basically every point needs to move 2 units to the right. And that's quite easy now for us to sketch. And that is the translation of the graph, the inverse graph, which you see in blue, to the green graph. The last one is an inequality. It says, use your graphs to solve for x if log of x minus 2 base 3 is less than 1. Now remember that the blue graph is the graph log x base 3. And the green graph, we move the graph 2 units to the right, is actually log of x minus 2 base 3. So we're now focusing on the green graph. And they want to know, when is this graph less than 1? For what x value? So there's our line, y equal to 1. And that's a point we need to trace down on the x-axis. And if we find that point on the x-axis, we got 1, 2, 3, 4, 5. So the green graph, we want to know, when is it below the line y equal to 1? Because that's what the question is saying. So if we trace that point, as I told you earlier, that point is 5. But then we are restricted because the green graph has an asymptote sitting at 2, 1, 2. So it can only be from 2 to 5 and not inclusive. Therefore, we use a round bracket. Any questions on that? So there's our first one, an introduction to the exponential graph and the log graph. Now I'm going to look at some of these graphs since we're talking about exponential. It says write down the equations of g and h in the form y equal to. So if we look at the questions, we have g and we have h. So if we look at the original, f of x is equal to 2 to the power x. So g of x is shifting the f graph 2 units to the right. And it's saying f of x to the minus 2. So in this one, all we have to do for g, where you see x, we will make it x minus 2. And the h graph is actually the inverse of f, which we can find. So we're ready to start. So the g of x is equal to f of x minus 2. And where we have an x, we will replace that with x minus 2. And there we have the h graph. Okay, that is our, our g graph that we wanted. So g of x is actually equal to 2 to the power x minus 2. The next question is the h1. The h of x is equal to f of minus 1 of x. And here's where we find the inverse. So we're going to do that very quickly just for practice. We're going to make the inverse. First point is to swap x and y. So we'll say x is equal to 2 to the power y. And then we will bring in a log. Y is equal to log x, and the base is 2. And that will become our h graph. And I just want to erase my writing so you see the PowerPoint. And there we have it, log x base 2. And then we'll be able to draw these graphs. It says on the set of axes where f is already drawn for you, add the graphs of g and h. And once again, it's the same story. Is this graph is going to move 2 units to the right. For f, if we understand translation, that graph is moving 2 units to the right. There we have it. And then the h graph is the inverse of the black graph. Remember that? The h graph is the inverse of the black. And remember what I said when we want to inverse? That 1 on the y-axis will go to 1 on the x-axis. And the black graph asymptote is the x-axis. So the inverse will have the y-axis as your asymptote. And you can trigger any point. If we look at this point 1, 2 on the black graph, so on the inverse, that point becomes 2, 1. And there we have our inverse. Remember, your inverse is a reflection on the line y equal to x. You don't have to draw that line in. But once again, we're going, can you see on one on the y-axis moves to 1 on the x-axis. And if we trigger a point 1, 2, that point will become 2, 1 in the inverse. And there your black graph had the asymptote, which is the x-axis, that becomes the y-axis. And the next question is, solve for x if g of x is equal to h of x. What they simply want to know is the point of intersection of g and h. Okay, so if we look at the g graph, that is your red graph, and your h graph is your blue graph, and we can see that they intersect at that point, which is x equal to 2. So we can pick that out directly from the graph. All right, let's go to some past paper questions. So now I want you to work with me. If not, some of you might fall off to sleep. So we will use the chat forum. You can put your answers, or you can even use a mic. All right, so we got the first question that's coming up. It says, see given diagram below, g of x is equal to k of x, and k is greater than 0, and we have a point given the graph is a point. Determine the value of k. So let me give you a minute. Go for it. As soon as you get an answer, you can put it in the chat, or you can put your mic on. Give you about 2 minutes. All right, we got 2 answers come up. Let's just quickly work it out together and see if we can get the same answers coming up. So all we had to do to find k, we know this point is a representation of a coordinate. So there's our x, y, it's on the graph as well. So we can say that's x and y. So we're going to go to our graph. So for y, we're going to put 36, which is equal to k, and the x value is squared, and that'll give us k to be plus minus the square root of 36, which is plus minus 6. But they did tell us that k is greater than 0. Therefore, we can conclude that k is equal to 6. Well done. I see a lot of 6 came up. The next question is to find the inverse. All right. So to find the inverse, I think that's quite simple. We discussed that. We know now that g of x is actually equal to 6 to the power x. Step 1, swap x and y. That will become x is equal to 6 to the power y. And then we're going to have y is equal to log. You'll notice the base is 6. It'll stay as 6. So it's log x base 6. And there we have the inverse. Okay, so remember our value was k was 6, and we have the log graph. So we're moving on. Okay. Now let's write the equation down. And for those of you who forgot about it, just to keep track of it, we have 2 equations. We have g of x, which we found was equal to 6 to the power x, and we found y to be equal to log. And I think it was log, let me just go back. So log x base 6. All right, that was our g graph actually. The g of -1. So looking at this question, for what values of x is g of -1 of x less than and equal to 0? Let me give you some time. Quickly try it out and then we can discuss it. As soon as you have an answer, put it up. Then I know you finished. Right, I got one answer coming up. Let's wait for a little more. All right, let's get into this question. Now, remember, if we actually quickly sketch this, just to give you an idea, this will be the inverse. And this point here on the graph, it will be 6 to the power 0, which is actually 1. 6 to the power, the x value is 0, so 6 to the power 0 is 1. And that point actually moves here to 1. So the question is, when is g of -1? In other words, when is log x base 6 less than and equal to 0? You can actually solve it, bring it back to exponential form. If you actually bring it back to exponential form, it will be x less than equal to, your base is 6 to the power 0, so it's x less than and equal to 1. But basically we want to know is, when is this red graph below the line y equal to 0? And you'll notice it is from 1, but we have an asymptote sitting right here, and that asymptote is sitting at 0. So therefore, we are restricted by the asymptote. So we'll say x less than or equal to 1, but greater than 0. Or we could have said x is an element from 0 to 1. Cannot include 0, it's an asymptote. We are including 1. So I'm looking at the answers, and I see lots of you have missed out the asymptote. Okay. Any questions on that? Okay, so then we're ready to move on. I just want to erase my board. So you will notice, I'll give you some time, I'll give you a minute, write down the range of, it says write down the range of h if h of x is equal to that. So let me give you some time before I get into it, and put your answers up. Somebody wants to know how I got 1. So remember that what I tried to explain to you is this is the y-intercept, and at the y-intercept the x value is 0. So all I did was, that is 6 to the power 0. Any number to the power 0 is 1. So that point there, when you get into the inverse, will move from the y-axis, because it's an inverse, that 1 moves to the x-axis or the x-intercept, and that's how I got the 1. So that clarifies. Okay, we on the question. I'm just waiting for an answer to come up. Okay, I'm back. I think I had an internet dip, took me out, and then he brought me back into Zoom. Okay, did we have any answers come up on the chat?
No, sir.
No, not
one answer. Wait, so the question was hard, sir.
Hey, the question was hard.
Sir, can you share your screen back so I can't see anything?
You're not seeing my screen. Sorry, I got kicked out. It's quite rude. This
No
internet.
problem.
And I'm back in now. Okay, can you see that now?
Yes, sir.
All right. Okay, so I'm looking at the chat line again. So if we look at this question that I want to go into now, since nobody gave me a good answer, so let's go through it. So let's look at what's happening here. They want to know the range. Now, if we look at the range of the present graph, which is the G graph, the range of the G graph is, range is y. Y is greater than and equal to, actually not equal to, that's an asymptote. So y is greater than, anyone can tell me, what is the range of the G graph, the one you see? Don't feel shy now. Give me an answer. What do you think the range of the G graph is? Nobody wants to try? Okay, it's actually y is greater than 0. Somebody said y greater than 1. It's actually y is greater than 0 because this is the asymptote. Okay, so that's our range of the G graph. Now, what's happening to the, we want to find the range of the H graph. So the transformation is we're moving the graph 3 units to the right. If we move the graph 3 units to the right, we're moving on the x-axis, which does not affect your range. And then we're moving the graph 2 units up. So we're going to move the graph 2 units up. So that asymptote will actually go to 2. Now that affects the range, which means that the range of h of x would be y greater than 2. Okay, so that is your range. Are we happy with that? So let's go to another question. Now, yes, last night I covered hyperbola, and today I'm covering the log graph. So I'm now merging. I'm merging the log graph with a hyperbola. So let's go through this question and see the challenges that lie ahead. So it says in the diagram, g of x is equal to 2 over x plus p plus q. Notice they did not give us the asymptotes, all right? If we look at the graph, there's our x-axis, y-axis. We have the y asymptote, which is -1, and we have the x asymptote. And the x asymptote for the hyperbola is, we don't have it. It's e. So we don't know what the asymptote is sitting right there. Okay. Then it goes on to say y is equal to -1 is the horizontal asymptote. So if -1 is the horizontal asymptote, it means the value of q has to be -1. Then B10 is the x-intercept of f. That is your actual log graph. AT1 is a point of intersection. So they give us the point, they're actually giving us the y value of the point of intersection, which is 1, but they are not giving us the x value. The vertical asymptote of G intersects the x-axis at E. So note, we don't have E. So B is a different point. Don't confuse B and E. B is actually 1. And the vertical asymptote, okay, we covered that. OB is equal to OE. So that's very interesting. If OB is equal to OE, we know the distance from OB is 1. So immediately we can go to our diagram. That's good information to help us. So if OB is equal to, let me read that again. OB is equal to BE. So from O to B is 1 unit. So from B to E will be another 1. So immediately we know the point E has to be 2. And then the question is, write down the range of G. Now, a good thing to do in this graph here, because it's so complex, is to take out a highlighter, which I'm going to do as well, and use 2 different colors. So if we look at G, just highlight it. So you can see the difference between, that's a G graph, and the F graph is in black. We don't want to confuse that with the x-axis, so I just want to put that in blue. So we can see our graphs clearly. Very helpful to do that. So the first question is to write down the range of G. Okay, range is y. So for a hyperbola, it's going to be y is an element of reals and y not equal to the asymptote. And if you look at the y asymptote, the y asymptote is actually y equal to -1. And there we have our range. The next question is to determine the equation of G. So to determine the equation of G, we need to find P and Q. So I want you quickly put it on the chat for me. What is the value of P and Q? So as you have it, put it up. Okay, did anyone get their answers yet? All right. So if we look at the graph, if g of x is equal to 2 over x plus p, I'm actually looking right here. So remember, p represents the vertical asymptote. And if we look at the vertical asymptote, we said the point E is 2. So we should be getting x. We got to change the sign. So we're going to get g of x is actually equal to 2 over x minus 2. Okay. And then the q represents the y asymptote or the horizontal asymptote, which is in this case -1. Okay, so we found the equation that was requested. Okay, let's move on. Calculate the value of t. I'm going to write that equation down again. So remember, we found the equation g of x was actually equal to 2 over x minus 2 minus 1. And now we want to find the point of intersection. Well, to find the point of intersection, you need to know the equation. So let's quickly write down this equation for f. F of x is equal to log x base 3. So we're going to write that down. For those of you who don't know, f of x is actually equal to log x base 3. So the point of intersection is sitting. Now we already have 1. It gave us the y value to be 1. All we have to do is find the x. We don't have to equate both the graphs because we can sum the value of y to be 1 in any equation because the y value is given and to find the x. So I'll think in this case, it doesn't really matter which one, but most of you are more familiar with working with the top one. So what we're saying there is 1 g of x, the y value is 1, and we want to find the x value. And then we can bring our y's to one side. 1 minus 1 becomes a plus 1, giving you 2 over x minus 2. And then we can cross multiply. 2 times x minus 2 will be 2x minus 4, which is equal to 2. 2x is equal to 6. Dividing by 2, we're going to get x to be 3. And therefore, we can conclude that the value of t, if you're looking at it, is actually 3. Okay, so as you can see, there's our value. The x value there is 3, which is represented by t. Okay, let's get to the next question. Now it says, write down the equation of f of minus 1, the inverse of f. So remember that our f of x equation was log x base 3. So to find the inverse, we swap x and y. F of x is y, it now becomes x, which is equal to log y base 3. And then we're going to write in exponential form. Okay. So our base is 3. That'll be our exponent is equal to, and there we have our inverse, y equal to 3 to the power x. It's set in the form y equal to, so we can stop at that form. Okay, now it wants to know for which values of x is this inverse. Remember, this is the inverse. Okay, f to the minus 1 of x, that is our inverse. When is it less than 3? Let's give you a chance to work that one out. When you have the answer, you can put it up on the chat. Give you about a minute to think and work that one out. All right, I've got an answer come up. Well done, Mr. All right, well done. Let's see if you got it right. So basically, they want to know when is the inverse graph. Now remember, the inverse graph is represented by 3 to the x. When is it less than 3? So our bases are the same. That's 3 to the power 1. So that means x is less than 1. But if we look at the graph, which will be the inverse, remember the inverse would be restricted by the asymptote. Always remember that. And if we look at the F graph, the asymptote is the y-axis. So that is the log graph. The inverse is the exponential graph. So the asymptote will change now to the x-axis. So that means we will have a restriction. Okay, let me do that again for those of you who cannot see it. Let's use a highlighter. Highlighter come alive, right? So right now, if we look at the F graph, that is your asymptote. So when we find the inverse, the asymptote will now shift here. So that means x is less than 1, but we cannot go beyond 0. So actually not, sorry, my mistake. Okay, in this graph, if we think about the exponential graph, and I want to draw it for you very quickly. So if that log graph is drawn, when we draw the exponential graph, it's going to be looking exactly that. The inverse will be the exponential, and at point 1 will move to 1. So we are now saying x is less than 1. Now look on the x-axis, there's no asymptote stopping that. If we look at the x-axis, all right, because we are bounded by the x-axis, which there's no restriction. So that means we will accept our answer, x is less than 1. So if we look at the line 1, from the point 1 on the x-axis, the graph goes on to infinity. So it starts here and it's not stopping. Can you see it goes on and on and on? So there's no restriction. Okay. If we're working with the range, it'll be a different story. So answer there would be x is less than 1, and we'll take it as it is. The next question, determine the point of intersection of the graph of f and the axis of symmetry of G that has a negative gradient. So we know the axis of symmetry for a hyperbola. So if we look at that, that's the G graph. So axis of symmetry, because it's a negative, y will be equal to minus x plus c. Okay. Now, if we look at the asymptotes, where are the asymptotes actually intersecting? Okay, it actually intersects at the point D. And we know that the point D is, well, the point E is 2. So that's actually a 2 minus 1. Okay, so we can substitute that in. Y is 2 minus X, which is, sorry, Y is not 2, my mistake. Y is negative 1. Let's take that out. So we got negative Y, Y is, a pen is playing games with me. Okay, so we have our Y to be going to this, put our X, put our Y. Our Y is negative 1, which is equal to negative, and our X value is 2 plus C, and take our C on minus 2, and that's it becomes plus 2, which gives you C to be 1. Therefore, our equation is Y equal to minus X plus 1. Okay, so we have our axis of symmetry. Now, we carry on reading the question. It says determine the point of intersection of the graphs of F and the axis of symmetry of G that has a negative gradient. But they want the point of intersection of F and G. So now, if we look at the graph, if the y-intercept is 1, the x-intercept here okay, so we know that the x-intercept, we let y to be 0, will actually be x equal to 1. You can substitute 0 for y, and the minus x goes on the left, becomes x equal to 1. And then we also know that the y-intercept here would be 1. If you go to the graph, the x-intercept, for it to be 1, has to be at that point 1, 0. That is the point 1. And the y-intercept will be somewhere there, right? So you'll notice that if we actually draw the line, which we can do, just to get an idea of what I'm actually doing here, that is the axis of symmetry. But the point of intersection is right there at 1. It's a common point. So we can conclude that the point of intersection is actually the point B. And that point B is given to be 1, 0. So that is the point of intersection. All right, any questions?